This is the second part of the Genesis Integrated Board Flow video series. The first part covered the What-IF frequency planning tool. This second part covers the Spectrasys RF architecture system design tool. Next, we will take the IF frequency and the mixers that we used in What-IF and transfer them to Spectrasys to start our system design. The next step is to design our receiver. I've opened with a blank schematic in Genesis, and you can see the schematic toolbar. There's an icon that looks like an op-amp that says Part Groups Toolbar. If you click on that, it opens up a variety of toolbars. There is a lump toolbar, there's a microstrip toolbar, and then we have the system toolbar. If I click on it, it opens up our Spectrasys system toolbar. And from here, you can click on different icons, and there's a pull-down menu. So for an amplifier, I'm going to select the second and third order amplifier. I'm going to zoom in using my mouse wheel, and I'm going to use the default values on that amplifier. I'm also going to select a bandpass filter, Butterworth, and drop it down. Let's make that bandpass 2300 to 2500, because if you remember, our lower frequency was around 2450, so that's going to be our first RF filter. To connect these up, we can either drag them together, such as this, and they connect, and then they stay connected. Or if you hold down the Alt key and move it, it'll disconnect them, and then we can just draw a wire between the two parts and connect them up. You just hover over a node and it draw a wire. So also, if you notice, we have a tab over to the right that says Part Selector, and from there I can go to, we have the eGWare library, which is the same parts in the toolbar but in a tabular form, and you can sort those by the different types of models. And so if I click on System, it shows all the different system models, and you can sort by clicking on any header. I can also go to the Hittite library and resort by clicking on the name, and you can see the mixers are at the top, and I can select the mixer that I selected in What-IF and place it on my schematic, move it over, and connect it up by dragging it in place. Also, you can create custom libraries, and I have one called Dual Band Demo here that has some of the parts I want to use. I'm going to grab my multi-source and put it on the schematic, and I also have an IF filter and an LO I'm going to put on my schematic. So what I'm going to do is connect up my source. I'm going to close my Spectrasys toolbar. I'm done with that. I'm going to use the IF filter in just a little bit, so I'm going to put it down below, and I'm going to connect up my LO to my mixer. And I just click O on my keyboard to put an output port. So now we have our schematic, and the next step is to analyze the schematic. So you go back to the workspace tree, New Item button, and under Analyses, pick Add System Analysis. And I'm just going to use the defaults in the System Analysis. I'm going to click OK. It's already simulated. So we've simulated, and now if you want to look at the spectrum at any node, all you have to do is hover over a node, right-click on the node, and I'm going to look at our output spectrum to say Add New Graph or Table and New Power Plot. So it creates a graph of our spectrum at that node, and if you hover over any of the spectrums, you can see it tells you how it was created. So here is our oscillator minus our source, and then over here is our source plus our oscillator, and you can see any of the items that I hover over, it tells me how they're created. I can right click on it, say Create Info Balloon, and it actually gives me a persistent data, and it's telling me that this spectrum is the source minus source plus 2 times the LO, and it tells me the path and how this was created. So if we go back, I'm going to tile the schematic and the graph, and what I want to do is put in my IF filter, so I can remove my output port, put in my IF filter, and connect them back up, and then I'm going to resimulate, and you'll see immediately that putting in our IF port has filtered out many of our harmonics and intermods, and all we have left is our desired signal. I've now taken the circuit that we created, as you can see here at the top, and I've combined it with our 5350 megahertz source, and you can see now we're going through a switch after our first IF, and then we have a second IF at 70 megahertz. And you can see these switches are all ganged with a slider here where we can tune between the two switches. If I want to tune the switch, I can move it to position 1, and you can see that the whole circuit will resimulate. Only takes a few seconds to resimulate, and all of the switches switch to position 1. Also, I can now, if I want to hide my workspace trees, I can either use the auto hide features like we have for the part selector, or I have an icon up here that hides all the dockers and gives me a complete window view, so I have the schematic in the whole window. I'm also going to minimize this and show you another capability of Spectrasys, which is that you can plot any path through a circuit and look at parameters such as, in this case, we have channel power and noise figure. So you can see we have this upper path through the circuit, and the same path with the node numbers is shown across the bottom of the graph, and you can plot, we've plotted the channel power and noise figure as it progresses through this path. We can also, if I bring the dockers back so that we can see it, we can also plot this in a tabular form. As you can see here, we have the node numbers and then the parts. We show the frequency as it progresses through to the first IF, the second IF, the power, the cascaded gain, and the cascaded noise figure. That concludes part 2 of the Genesis board flow series. Please continue to part 3 to continue the series.